Hello, and welcome to the John R. Kirk Planetarium. I'm David Meer, a senior studying physics and astronomy. Today, we're going to be looking at some of the constellations you'll be able to see tonight, September 3rd. We're going to look at some of the biggest things in the universe, from some of the biggest stars to the biggest structures in the known universe. We're going to end by talking about Saturn and its glittering moon, Titan.
Welcome to the walkway over the Hudson. Here we are looking at the sky as it will be on September 3rd at just about noon. We've got the sun in the sky and the cardinal directions noted on the ground. At the moment, we're facing south down the river, but we can look in any direction we want. Now, we want, of course, the sun to set. We want to be looking at nighttime, so let's speed time up. The sun's going to be setting a little bit north of west because we are currently in the summer. In the winter, it will be setting a little bit south of west, and on the equinox, which is coming up, it's going to be setting dead west. Now, the sun's going to come down, and the stars are going to come up. I'm going to slow this down so it's a little more impressive. I'm going to face us south so we can see some of the constellations I'm more interested in starting with. So we're going to see some objects starting to shine, the brightest ones, of course. And then as time progresses, we're going to get a darker sky and see the even fainter stars show up. I really think it's super impressive. So we're looking at a bunch of different stars. I'm going to zoom us out a little bit so we can get a picture of an even broader scope of the sky. Let's stop right here at just about 8:30. I'm going to get rid of the atmosphere and make it even easier to see what's going on. Now we're going to start with the summer triangle. The summer triangle is up in the sky and of course very easy to see during the summer. We've got three of the brightest stars in the sky. We've got Altair right here, we've got Vega right here, and Deneb, which looks like it's hiding a little bit, right over there. So these three stars will give us our triangle. Now, they create a triangle in and of themselves, but there are more than just those stars and those constellations. Each one has their own associated constellation. We have the powerful eagle Aquila with Altair down here. We've got a majestic swan up here with Cygnus, and we have the mythical Greek instrument, or I should say the ancient Greek instrument, Lyra. Now, the first thing I want to talk about in the summer triangle is that star I'm currently pointing at, Deneb. So, Deneb is a huge blue supergiant star. If we're going to talk about some of the biggest things in the universe, we've got to start with a big star. So, this is 20 times the mass of the sun. That's really impressive. I want to start there. That is a huge star. But even though its mass is only 20 times, its width, its size, is even bigger. It's got 200 times the radius of the sun, which means it takes up way more space in space than our sun does. Now, this is a blue supergiant star, which means it has a relatively short lifespan. We're talking hundreds of millions of years as opposed to tens of billions of years with our sun. This means that Deneb is going to burn very bright, very hot, and very quickly compared to our sun. And you can even go the other direction. Red dwarfs, much smaller stars than our sun, will burn much fainter, much cooler, but for trillions of years. The next object I want to talk about within the summer triangle lies within the constellation of Lyra. So, Lyra only has a couple bright stars, the brightest one, of course, being Vega, but there are many other things going on. I'm going to pull up a map of what's called deep space objects. Now, these are objects in space that we can't see with the naked eye, but we can see with telescopes. They are not stars and they are not planets, they are other things. What I want to focus on is right here, what's called M56, a boring name for a very interesting object. This is a globular cluster. This cluster is absolutely massive. This cluster is 84 light years across. 84 light years. For reference, the distance between our sun and the closest other star is about 4 light years. That means this thing is huge, and it contains about 23,000 masses of the sun. This thing is absolutely massive. In fact, we think it may be part of what's called a dwarf galaxy remnant, what's called the Gaia sausage. That was a dwarf galaxy that was once swallowed by our own Milky Way, and this could be a remnant of that galaxy. That would be really cool because that means if we can study M56, we can tell relatively close up what the composition and properties of other galaxies may have been. The next object I want to talk about is on the scale of galaxies, but in order to see it, we're going to have to leave the summer triangle. So let's clear this up a little bit. Let's get rid of some of these friends. Don't worry, we will come back to them. But let's say you wanted to look at a different part of the sky. Let's say you wanted to look in the north. Well, then I would point you towards one of the biggest, most famous, easiest to see constellations in the night sky, the Big Dipper. In order to see it, I would point out 7 stars. 1, 2, 3, 4, 5, 6, and 7. Creates kind of a handle shape and then a bucket. So let's make it a little easier to see. Let's connect the dots. You'll see it's actually part of a larger constellation. Now, I don't want to focus too much on that larger constellation. At the moment, I just want to use the Big Dipper. I want to take its handle and see the curve that it makes. I want to follow that curve over here to this bright star. Now, you could call that a curve, or you could call it an arc. And it makes sense if you want to call it an arc, because this star's name is Arcturus. So here we have Arcturus right here, and it is part of the larger constellation of Bootes. So, in order to find Bootes, first you've got to find Arcturus, and then you're finding a kite. So, the kite kind of extends up here a little bit. Oop, looks like I was off by a star, but you have kind of this kite shape here. And it's got 2 legs that extend down in either direction. Arcturus is a hero, and depending on the myth, it can have different meanings, different origins. But something I want to talk about within Bootes is another deep space object. It's actually not available here, so I'm going to put it on the screen right now. This is NGC 558. This is a Seyfert galaxy. In the center of this galaxy is a supermassive black hole. This black hole has a mass of 65 million solar masses. This thing is huge. It's about 1% the mass of the entire galaxy. This thing is so massive, and it is actively eating more material, getting bigger and stronger, and it's ejecting out and it's spitting out high energy gas and high energy radiation. We can detect all these things, which let us know that this galaxy is unique. It is unique because of its black hole, and those structures, those black holes spinning out high energy gas, can actually help us see some really cool things and the biggest structure in the universe. So, in order to see that, we're going to have to come back to Stellarium for a second. So, we had Arcturus down here. Here, let's bring the horizon a little bit more into view. We've got Arcturus in the west, and way up here we had Vega. And if you create a line going straight through, you can see 2 different constellations. One of these is a northern crown, and its name literally means northern crown. This ring right here creates Corona Borealis. So, right here, we've got that ring shape, Corona Borealis, and of course a little crown. Here, if I get the name out of the way, it's a little easier to see. Now, who's deserving of a crown? Well, kings may be one answer. The other answer is a hero. And there is the most impressive hero, basically, of all time in this part of the sky. Right here, you've got the torso of Hercules. Hercules is wrestling a hydra from one of his labors. But I want to get there. But before we do that, I want to point out kind of the reason why I wanted to point out Hercules and Corona Borealis, which is what is beyond them. If you took a telescope, some of the most powerful telescopes we have, and you point them in that direction, you would end up finding the Hercules Corona Borealis Great Wall, which is the largest structure in the known universe. So firstly, what do I mean by structure? Well, galaxies are grouped together in clusters. Clusters are grouped together in superclusters. And if you look at a map of the superclusters in the universe, you see this web stringing out clusters between each other like little links, like little neurons. And within these neurons, you can find the Hercules Corona Borealis Great Wall. This collection of superclusters is 10 billion light years across. It would take light almost the entire age of the universe just to travel from one end to the other. This thing is huge. Our universe is about 13.7 billion years old, which means this thing is just crazy big. It is at least 10% of the universe's length. The other impressive thing is this object's mass. This puts basically anything I've ever talked about to shame across any planetarium show. This weighs about 20 billion solar masses. 2 followed by 19 zeros. That's how many suns, entire suns, could fit into this object. This is huge, this structure. It weighs about 100 million times our entire galaxy. Our galaxy has billions of stars. Most of those stars have planets. This is just absolute. The size of it boggles my mind, and it just puts anything else to shame. But how do we actually know that this Corona Borealis Great Wall exists? Well, if you look at the Seyfert galaxies, those galaxies like NGC 5548 that I was talking about, they give off tons of energy. If that energy happens to be pointing towards us, think of it like kind of a lighthouse. If that light is pointing to us, we call that a quasar, or a gamma ray burst. It can give those off. Once we can see those, we can map the universe using those gamma ray bursts. From there, we see that there's an unusually high amount of them in this direction of the sky. So that's how we can start to map out the universe and discover this Corona Borealis Great Wall. Now that's a lot of heavy science stuff. I want to bring it back a little bit. Let's talk about what we can actually see in the sky. Because while, all this stuff is great, it's not as visible without some of the best telescopes in the world. But we can see Hercules. So let's talk about Hercules for a second. As I said, he's done a number of labors in the mythology. I want to talk about a specific one, his quest for the golden fruit of immortality. Now, we need one other character for this, and I want to bring Prometheus up. Now, Prometheus does not have a constellation, so let's represent him with Bootes. Bootes represents a bunch of different people in a bunch of different mythologies. I'm sure he won't mind. Now, Prometheus knew where the apples were. Or not necessarily apples, but where the fruit were. The thing is, he was a little bit preoccupied. You see, Prometheus had brought humans fire, so go thank him for that. he gave it to them against Zeus's orders. He was not supposed to, and therefore he got punished. The way he was punished was that Prometheus was chained up, and an eagle, which is actually represented in the sky, would peck at him for all eternity. And that eagle is represented in the sky, and we already looked at Aquila. So now our stage is set. Hercules comes up to Prometheus and explains his quest. Prometheus says, "I'll help you if you help me. Free me from this beast and I'll tell you where the fruit is." So Hercules knocks an arrow and launches it at the beast. And that arrow is actually in the sky as well. It's actually right above Aquila, right here. It's a very small constellation, but 1, 2, 3, 4. Here we have Sagittarius, otherwise known as an arrow. There you go. So that arrow pierces Sagittarius in its side, and it keels over. Hercules frees Prometheus, and Prometheus guides him on his quest. Now I want to talk about Sagittarius a little bit, because there is something very interesting going on. If we look up a specific star, VSGE, as a star within the constellation Sagittarius, if we zoom in, it's so insignificant that it's not even in this program. However, eventually it will be very, very important. In about 2083, give or take about a decade, this star will go nova. When it does that, it will become one of the brightest stars in the sky, and many of us will be around to see it. It is a cataclysmic, variable, binary system. One star is stripping mass off the other, and eventually that stripping of mass is going to get too great, and the star that's eating it all up will explode. That will create an incredibly bright night sky, and it is going to look absolutely amazing. Now, when I say Sagittarius, I know many of you probably think I'm not done with my word. I say Sagittarius, you want to finish it Aries. Now, we can actually go there, and I was intending to talk about Sagittarius. Now, just for a bit of etymology, why they're related, Sagitta means an arrow. So then it's natural to understand that Sagittarius means the archer. In order to find him, we're going to be looking at this big cloud here. Now that may look just like a cloud, but in reality, it's something a lot more interesting. If I pull up Cygnus, you can see that we've been looking at a lot of constellations within this line. That line is the Milky Way. I want you to think of it like you're in a pancake. The Milky Way is a big pancake. You'll see a few bits of fluff, a bit of pancake mix above you, see a bit of pancake mix below you, but most of it is going to be off to the sides. That is exactly what's going on with the Milky Way. Now, if we follow it down here to keep going with the food analogies, we've got a teapot. So we've got kind of the head of a teapot right here, or kind of the base of it. We've got the lid up here with this triangle, got a handle, and then we've got a spout just here. And you can almost say that the Milky Way is the steam coming from the teapot. Or you could even say you're making milk tea and the Milky Way is coming out of it. Either way, this teapot is Sagittarius. Now, to continue along with the mythology, Sagittarius is, of course, a centaur, a creature with the lower body of a horse and the upper body of a man. This specific centaur is Chiron. Now, Chiron is a son of Kronos. Now, in the Greek, Kronos was the old king of the gods. He was overthrown by Zeus. But in Roman, you're a lot more likely to recognize those names. Instead of Zeus, I may say Jupiter, and instead of Kronos, I could say Saturn. In fact, both of those planets are currently in the sky. Right here, this very bright object, one of the brightest in the sky at the moment, is Jupiter. And right next to it is Saturn. So let's zoom in on Saturn for a second. As I said, I eventually want to get to talking about one of its moons. But here we go. Here is Saturn in all its glory. So Saturn is the second biggest planet in the solar system, behind Jupiter. And it, of course, is most famous for those rings. But those rings are not a permanent structure. Those rings were once a moon, and that moon got too close to Saturn. And it's fun. The actual technical term for what happened is that the moon got spaghettified. It got stretched on one end and squeezed away due to the tidal forces when it gets too close. Think of it like your feet are getting pulled a whole lot stronger than your head. So your whole body, or in this case a whole moon, is ripped apart, and these rings are the remnants of that moon. Now the little divots in the rings, you can see right here and right along here, they go along in a whole wide arc. Those are the moons of Saturn, the non-spaghettified moons, having an influence on its gravity. Now, if we zoom out a little bit, we can see way over here, we've got a very interesting looking moon that's kind of a different color from all of them. And that is not a coincidence. Here we are at Titan, and I want to finish this presentation by telling you some very cool stuff about Titan. So now I want to, of course, change pace and tell you about this glittering moon, tell you about Titan. First off, just want to mention that this is a real picture you're looking at right now. This was taken by the Cassini probe, which we'll talk about in a bit. But this is Titan in the background. It's not blurry or hazy on purpose or because of the camera. We'll actually see that's part of what makes it unique. And of course, the rings and just one other minor body or moon orbiting around Saturn. But to me, that's an amazing picture. So first off, why is Titan special? Well, firstly, Titan is the second largest moon in the solar system. That means it is relatively massive and has a lot of gravitational influence. Therefore, it can hold on to an atmosphere. Our moon, for instance, does not have enough gravity to hold on to an atmosphere. And that's why if you land on the moon or take a picture on the moon, you're never going to see a blue sky. It's just going to be blackness all around, like empty space. Now, Titan is also very far from the sun, of course, being as far away as Saturn. That means it has a very cold temperature and has a methane cycle. The way we have a water cycle, water will flow into the ocean, evaporate up into the clouds, and then rain down. That same cycle happens, but with liquid methane. On Earth, methane is just unequivocally a gas at all, in all forms. And because of this methane cycle and this atmosphere and its relative size, it has a lot of distinct features, which make it very, very special. Basically, no other moon has the same types of features that it does, and in a lot of ways, these features can be very similar to Earth. So we have sent previous missions to Titan. As I said, that Cassini probe never actually landed on Titan, but it flew by and took a lot of important information that actually was processed in this study. We have actually landed on Titan, and it is the furthest landing away from the Earth that we've ever landed something on. We've sent probes much further. We've sent them to Pluto and beyond, but they were just to take pictures, not to actually land on the surface. This picture on the right is an actual picture of what the world of Titan looks like. It was an actual picture taken in 2005. That was the Huygens mission. And in 2026, we're going to have a dragonfly land, as shown in this picture here. Now, this dragonfly is unique. Well, first off, we don't have any other hovering drone-like probes anywhere else in the solar system. However, Titan's low gravity and very thick atmosphere make it very amicable to a dragonfly. So, what actually happened? Why are we saying Titan's glittering? Well, we're seeing waves and tides and very interesting features on Titan's surface. We have waves about 20 centimeters tall. Now, that does not sound like much, but we gotta remember there's not very much going on Titan. It's not like Earth where there's huge amounts of geologic activity happening all the time. There's also very slight winds on Titan's surface, which can be significant when we're talking about the ability to spread molecular compounds, which we'll get to later. So how did we actually discover these waves? Well, basically, we looked at some of the Cassini information. We saw different bits of the surface looking at different brightnesses. Now, we're specifically looking at some of those lakes. So if I go back for a minute, the biggest body of water, the Kraken Mare over here, is about the same size as the Caspian Sea on Earth. So by no means huge in the way that Earth has their world oceans, the Atlantic and the Pacific, but it's still incredibly big. So these waves, combined with a relatively low wind speed, is actually pretty impressive. We saw the difference in light, actually, as little waves came up and down. They'd reflect the light differently. So all of this glitter is actually what was measured. And there we were able to determine that, well, these waves are significant and relatively tall on the scale of a moon. So why does any of this matter? Well, it clues us in that we can start studying the oceanography of Titan. Now, oceanography on other planets, that's a new field completely. Because, of course, Titan has liquid on its surface, but what about when there's water? There are alien exoplanets that we know about that are 1 or 1.5 times the size of Earth, but we think they're completely covered in water. Europa, a moon of Jupiter, is a huge, basically glacier with liquid water underneath. All of that is super, super interesting, and Titan could give us a first chance to start studying this alien oceanography. Earth's tides and waves of water were absolutely critical for life. We needed to mix around organic compounds and provide a place where things could easily dissolve. That may be able to happen with methane on Titan. We're not really sure what's happening. Now, it's very unlikely that there is currently life on Titan, but if Titan was ever much warmer, there could be a really good case that at one point there may have been life, or at least the conditions in which life could have evolved. Lastly, as I said, we want to be studying other moons, other objects, other places in the universe. This technique of measuring light actually helped us show that this is a technology that works. We can use this information to discover these things in the future. Now, of course, 20 centimeter waves are not exactly huge for a surfer, but if we use this same technique on a planet that is twice the size of Earth, we could see huge waves and huge mixing processes that can create all types of organic molecules. So that was the presentation. Here is my sources. I just want to thank everyone. Here, let's go back to that nice picture. Just want to thank you for watching this show. If you have any questions about the astronomy, about the mythology, about Titan, about the universe, please leave them in the comments. I'll get to them. I know this is posted on the new Paltz page, but don't worry, I'm going to be stalking this video and seeing how it does. That's just how I roll. Therefore, if you've got any questions, I'll be able to answer them. Otherwise, I want to thank you guys for coming on this virtual planetarium show with me, and I hope you check out some of the others, or even come to one in person once we open up again. Thank you.